yourself and then go into the details?
Okay, my name is Firmin Fornet. I'm an high school student, and I created an open source motorized hand I want to show you today. So,
Very good.
my goal with this hand was to find a way to make a motorized bionic hand affordable and accessible for everyone. So, like I said, I created my own, which I call New Hand. The question I will be answering today are how do you create a motorized bionic hand, and what have I already achieved with my project? So, how I started this project. I'm a big fan of robots, technology, and engineering. So in 2023, I created a little grip with cardboard and wood pieces. After a little bit of coding, I tested it and realized the grip could catch small objects very easily. The cost of these little things was really low, and I adapted the system to use it like a bionic arm. I created a control system based on a switch fixed on the arm, and I tested the prototype. I found this
Can you hold that up for us?
yes.
Can you hold that up for us? Because I can see you have something. Can you show it to us on the camera?
Because he's reading. He's reading his notes.
Yes.
Also, you should introduce
your
colleague.
I have a few notes.
Also, who is the other person in the video with you?
Hi, I'm his girlfriend.
Ah, excellent. Welcome.
So, yes. Oh, yes. I found the little group very useful, and I decided to buy a 3D printer to build another version with a lot of improvement, with the goal of making the hand fully open source. So after I identified several essential elements for building a motorized hand. The hand must be able to generate its own force and must not depend on the human body. This greatly increases the comfort and the number of movements the hand can make. However, this brings its own set of constraints. The second essential element is that the entire assembly must be solid and comfortable. The hand must not tire the user, must not get in their way, but rather help them. The first element is that the entire assembly must be solid and comfortable. I repeat myself. The challenge here is that I have to achieve all this almost exclusively with 3D printing and inexpensive components. The final particularly important point in the new hand project is that the hand must be easy for anyone to build. So in early 2024 for Christmas, I received the 3D printer. And the very next day, I started creating the first real version of New Hand, which I called New Hand Alpha. Using the 3D software, this hand here.
First hand.
This initial hand had basic functionality. It could grasp and lift small objects like a pen of Rubik's Cube. And it has the same grip control system as the cardboard prototype. To control the hand, I use an Arduino Nano, a little microcontroller, powered by a 9-volt battery. For the finger, I incorporate 4 mini servo motor just here. For mini servo motor, all controlled by the Arduino. I also designed a rotary system from the wrist. While this end was a prototype and not truly usable, I believe it was a very good start. So, the second hand, Nuand Pro, the most significant improvement over Nuand Alpha are its motor system and control. Nuand Pro uses large DC motor to close all the fingers simultaneously. With this setup, it can lift a maximum of 4 pounds or 2 kilograms before the motor stops working. I also developed a voice recognition app to control the hand using voice command. For this, I use a Bluetooth connection and an ESP32, which serves as a microcontroller for the Bionic hand. The hand can also be used in autonomous mode without a smartphone. For this, a small switch detects when the user closes or opens their elbow, and then the hand closes or open after 2 seconds, like the first one, but with detection when the arm is
unfolded. When it
Yes.
unfolds, it detects it in the second one.
Today, I'm going to finish the third version of Nuand, which I've named Nuand Flex. So this is this hand. This Bionic hand is the most powerful and usable one I have ever built. For example, it can lift 6 pounds or 3 kilograms and easily grasp a bottle, glass, or a smartphone. Yet it can still precisely pick up small objects. The hand is also fully waterproof up to the wrist, and it can work underwater for 30 minutes. To build this Bionic hand, I'm using 2 large servo motors for the finger and 2 smaller ones for the thumb. We can just see the 2 servo motor here. All the battery system, the control card, and the hand can rotate like this. So, I also decided to incorporate a new material, a flexible filament for 3D printing. Thanks to this improvement, it can print very strong joint for the finger. So, finger can with this little pieces, the finger can be stretched or be formed. However, flexible material pose a significant challenge. Only a certain 3D printer can use this filament, meaning many people wouldn't be able to print new hand. To solve this problem, I created a version of Nuand Flex that that doesn't require flexible parts. It's less strong it's less strong and resistant, but anyone can print it. The rest of the Bionic hand has also been improved. It can rotate like previous version, but this one is much lighter, smaller, and more robust and resistant. The control system has also been significantly improved for this version. I wanted a very intuitive system, so I decided to use electromyography technology to measure electrical signal from nerves and muscles. This step was more complex and took a lot of time to complete, but recently I created an EMG-based control system and I can now control the end with it. The best part is that I'm using a very cheap module, around $40. So the Bionic hand remains very affordable for everyone. I plan to improve this control system with better module, so it's a bit more expensive. Like Nuon Pro, the second version, Nuon Flex, also has a voice mode accessible through the mobile app. Compared to the first and the second version, this one is the most advanced and the most useful. I truly hope it can be used in daily life and genuinely help people. Later, once Nuon Flex is complete, I want to build the fourth and final version of New Hand. This Bionic hand needs to have the same capabilities as a commercial Bionic hand, but cost less than $200. I hope New Hand 4 can lift 10 pounds or more. This ultimate Bionic hand will be made from more resistant materials than PLA, and like Nuon Flex, it will use a flexible filament, though a version without it will also be created. The control system will thinking of improving the control system will be the same as Nuon Flex, and I'm thinking to improving the microcontroller by using a Raspberry Pi computer. So thank you to listening me, and if you have any question, please don't hesitate to ask.
Thanks, Fermin. So how much does this whole hand weigh, including the controls? How much does it weigh? Sorry.
The first version is around more than 1 pound.
500 grams. I don't know how much it is in pounds.
The second one is little more heavy. It lifts
1600 grams.
and the last one is around the same weight as this version.
So 1600 grams.
Okay.
Thanks to PLA, it's pretty light. Yes.
And what did you say the overall material cost was?
The entire end, this the first one was around $60. The second one 70, and the third one around 100.
Very impressive piece of work. I gather, have you had a recipient to test it with?
No, to test the end, I need to adapt all the system to my arm. So I print to test for example, to
Got it.
Attach.
Yes, the end. I need to print another version without all these parts to fit in my arm.
So what he's done is with this hand, he's got a muscle captors, and
Yes.
so he tests it on himself.
Sorry, so are you using like EKG to actuate them? Like, what is causing the servos to move? Is it EKG muscle sense?
Yes. This is EMG sensors to detect electrical information from the nerves.
I mean, the fact that you put this together, and someone asked in the chat about, did you do this entirely yourself from scratch?
Yes, entirely.
That's very impressive. You should be proud.
Thank you very much.
So have you demonstrated this in operation with the EMG sensors? Are you able to flex your hand and have the digits move?
You?
Has that worked?
Definitely, he has some videos if you would like to see them.
How
Yeah,
to
very
I'd
much.
love
share the screen?
So we're not sure how to share the screen. Would you help us? Maybe.
Yes.
Mm,
Um, I think there's a share button at the bottom,
Ah,
the
yes.
little green thing.
Yes.
okay. Um, you see it?
Yes. I just
The
I
host
could.
I think needs to accept the.
Yeah,
Sarah,
I
you need
think
to
you
allow
need,
sharing.
Pardon? Sorry, we
Sarah,
didn't.
you need to
It's
let them
yeah,
share.
yeah, you should be able to share.
Okay. Ah, yes.
Yep. Done.
Okay. So, here's pictures of the third hand. That's
That's a video of the second hand.
yes.
This is the third
So
hand.
Mm,
we can see the EMG control system with my arm.
bravo.
Nice.
That's incredible. Is that based on a library that you pulled?
Yes, that's the card I use is a Groove electromyographic sensor. I didn't build my own sensor, and yes, that's an library that I used to control the hand.
Hi, Furman. This is Ryan Saavedra from Alt Bionics. What did you say the EMG sensor was?
It's a little sensor to measure electrical signal from the
Oh no,
nerves.
I'm sorry. I just meant what is it called? So like from you said InMove, is it like a MyoWare or what's the
That's not the MyWare sensor, that's the Groove electromyographic sensor, I think. Yes, this is this sensor. Yeah.
Oh wow, okay. Gotcha. Yeah, I've never seen that before. Okay, cool. Thank you.
We have a few other videos.
In this video, this is a control mode of Nuance Pro, and of in Nuance 3, the Nuance Flex, sorry, the voice mode is.
Yeah, there's a voice mode on an app he created, so that you don't have to, so you can tell the hand what to do
Yes,
just with your phone.
exactly.
Understood.
That's amazing. I just want to say that's amazing. Like that's in our pipeline to actually do, and we build these hands for a living. But to see it actually done by y'all already at 16, like that's incredible. Because yeah, it's the huge problem of like EMG is not reliable. There's a 60% abandonment rate on prosthetics, and I think that could really help. So great idea on that.
So that's a great tip that this EMG Grove device seems like it may have gotten the bugs out of the system. But at any rate, standardized it in such a way that we could build on it. So that's a great tip. Furman, have you published this on the hub? Shared it on the hub?
Nuance Flex and Nuance Pro are published on my website on GitHub, but the last one is not totally complete, so.
So it hasn't published it.
Yes.
Okay.
But in a few days, I think I published.
Well, I think the people on this call are impressed by what you've done and would might be able to build on it if you are willing to share.
Thank you very much.
I have two questions actually. The first is, what do you want to do with this project? And I know Alt Bionics has posted asking what you're, are you hoping to take this to the next level? Are you hoping to publish this so other people can develop it and do it in different ways? What do you want to do? And the reason why I ask is because when you answer the first question, the second one will be, how can we help?
The things I want to achieve with Neon is to create the fully open source Bionic hands can be aussi performant que too powerful than a commercial version. No, open source.
So you're working to commercialize it? Is that what I gathered?
No, all the first, second, third, fourth, and fifth version are free open source, and maybe one day I can make the end relevant.
Like he wants to put everything he's learned on open source, but at the end maybe sell it.
Yes, but if I do this, the software is free open source too, même si je la vends. Le logiciel c'est toujours open source.
And how can we help? So I'll introduce myself a little bit. My name is David. I have a background in mechanical engineering. I worked in mostly medical devices. I worked in surgical tools, insulin patch pump, some prosthetics. I did that for 10 plus years. I love what you've done. I don't know if you're looking for design feedback, if you're looking for some help. I see a few things pretty quickly that your hand may, if you want to do a design review, if you want to bounce ideas, I'm happy to help. If you help with documentation, I'm happy to help with that.
Hello?
Sorry? Oh, so yeah, my question to you is how can we help?
La chose que je manque, c'est des testeurs. En fait.
Well, he'd really like to test it on someone and also get some feedback about how he could improve it, what he could do with it too, because right now it's just for charity, for helping people. But well, I believe it could become better, but yeah, that's what he
Like I said, I test the end on myself, but I really need feedbacks for people when the end is used in a quotidian life and daily life. So for now, nobody really use new end because nobody build this end.
So yeah, he wants to test it on people.
Yes. So
it sounds like Alt Bionics is volunteering to help connect you. My own experience is that getting user feedback is always the hardest part. One thing you might be able to do, where in France are you?
Limoges.
Well, sort of, we're in Limoges, which is in the Haute-Vienne.
What's the closest big city? Keep in mind, I'm from
Limoges or
Attends. So,
that's the epitome of being from America, not knowing.
so I don't know exactly, but I'm here and Limoges, but
The reason why I asked what the closest big city is,
I think Bordeaux.
Okay, so the reason I ask is in big cities, usually there's a big hospital. And in hospitals, very often they have prosthetic groups and recipient groups.
Yes.
And so what you might be able to do is Alt Bionics, and you guys should chime in, they might have recipients who are kind of vetted, who are communicated, who are volunteering for this already. But if you're looking for other people, my experience is starting with hospitals is a good place. Hospitals and other prosthetists. One other thing, just to throw out there is I know you're struggling with the load. You said you're trying to get to 10 pounds.
Yes.
As long as you're using cable drive, right?
Yes.
As long as the cable is pulling directly on the motor, you will always have a lot of limitation. What you can do is you can loop that cable. If it's a low friction cable, you can loop that cable, and then the motor will have to pull twice as many rotations, but half the torque. And that might be able to get you over the edge.
Yes.
All Bionics, I don't know if you guys want to chime in on recipients or design or.
Yeah, so yeah, I would agree. I would lean more towards finding a prosthetic and orthotic clinic because they're the ones who kind of handle patient care with people living with limb differences. But hospitals do sometimes have groups. I've found just not as many, more local clinics. But Limoges is only a few hours from France, and I would say if this is something that you really want to do, or sorry, not France, Paris. So if this is something that you really want to do, Paris has a lot of prosthetic and orthotic clinics that will likely have people to test your device. So, but yeah, we can have a call if you want. I can kind of walk you through what the process is for volunteers and how that looks, but it's not too difficult. And they're typically willing to give a lot of feedback on this.
Yeah. Okay.
And Furman, are you in touch with e-NABLE France?
No, but I speak with a lot of member of e-NABLE France, but no, I'm not attached.
That's great. You should feel free to reach out to Thierry Oquidam, who's the leader of e-NABLE France, and he may have some other contacts for you as well.
I have one question, just in the air like this, but how far do you think Germain could go with this bionic hand? Just in general.
Yes. Good question.
In terms of like, I mean, as far as you want. I mean, you have a lot of people who are willing to help you just on this call, but what you've done at 16 is very impressive. And yeah, I mean, I kind of started in the same boat, but I started much later in life. Like I started with cardboard, string, and yarn, and now we build bionic hands and are selling across the world. So I think you can take it as far as you want to take it.
Thank you very much. So maybe I need to show. See? Oh, oops! I just. Oh no! I broke all. Okay. So, have you another question about new hand or?
I have one more comment. Furman, I think, as you can see, we're all enthusiastic and supportive. The fact that Ryan is selling these devices and this is on his roadmap suggests that you two might want to follow up with each other. And I would encourage you both to keep us posted, but of course to see what you can do together. Once you've gotten to your stage, Furman, the invention and design stage, there's a whole different set of crafts required in order to get it out into the world. And it sounds like Ryan is ahead of you on that. So I'm grateful for everyone's participation and would encourage you to keep us posted and collaborate as you can. Furman, you should feel very free to ask for help or support. And I think this call proves that there are lots of people who will be happy to help.
Les deux problèmes principaux que j'ai, c'est que je peux pas la partager. Si peu de gens ont téléchargé. Il faut partager.
We do have a few problems. He does have a few problems with the hands, and so one is
to share and distribuer, faire de la communication.
Communication. He's struggling a bit with communication, trying to reach out to people so people know about it.
Votre personne connaît quoi.
Because he thinks it could help a lot of people, but he's struggling with that. Would you be able to help us with that? Yeah.
Yeah.
Oh.
I would imagine we can. What specific help with communication do you want?
Surtout informer les gens que ça existe, et les gens qui cherchent une main bionique.
Well, for the moment, he's trying to communicate it to big newspapers. So he just wants people to know about it, and so it will be on big newspapers. Or just also like people like you guys that know about the area that can help him. It would just be to like spread the word, sort of thing.
Yes.
Yeah, I just saw a note from Ryan about using his social media to highlight the work. He has over 1 million followers on TikTok and Instagram. So
Oh, that
I
would be
guess
great.
that sounds
Yes.
like a good
Yeah.
option.
Thank you.
Thank you.
That's
And the
great.
other,
Sounds like you should talk to Ryan.
yeah,
Talk to Ryan, and I think that e-NABLE France will be able to help you reach out to
Yes.
French press as well.
Yes, maybe I need to contact us and ask her help.
yeah,
Non, c'est tout.
yeah, that would be really cool.
I'd love to include this presentation in next month's e-NABLE newsletter as well, if that's okay with you.
Yes.
Great.
Ah, bon.
So that's a great start. I need to get off the phone, folks, but thank you all. Congratulations, Furman, and your
Thank you very much.
friend whose name I didn't get. Look forward to seeing
Okay.
you again.
And Furman, I sent you my contact info as well in a message, so feel free to reach out as well.
He'll definitely reach out, I think. Yeah,
Not on
organize some other calls.
unfortunately not on social media, but feel free to reach out. I'm happy to help with the engineering part of it.
And the same here, Furman. Feel free to email me, and I can help where I can. Great work. It's amazing what you've done at 16.
Thank you very much.
Well, I guess
Wow.
it's the end. Thanks for listening.
And thank you for the translation help there. I didn't catch
Yeah. Okay.
Yes.
I think Furman, one thing is just also I think it might seem because you've never met Ryan or myself or anyone else here, it might seem like you are hesitant to ask us questions. But like I gave you my cell phone number. Just shoot me a message on WhatsApp if you ever have questions about stuff. Because Ryan has been doing exactly this for the past 15 years now, and I've been doing it something similar for the past 15 years as well. So we're happy to help you.
Cool.
Cool.
Yeah.
De quoi? So
Okay. Well, we'll be in touch.
Thank you.
Looking forward to it. Good luck.
Bye, everyone. Thank you, Furman.
Thanks.
Congratulations.
Bye.
Bye.
Talk to you later.
Just trying to work it.